Hey guys, it's Miss Fendley. So today we're looking at section 5.4, equilateral and isosceles triangles. Our learning objective is to be able to use the base angles theorem and solve for sides and angles of isosceles and equilateral triangles. So quick review, when we talk about types of triangle, scalene triangles have no congruent sides, so all three sides are different lengths. Isosceles means that there are two congruent sides, and equilateral means you have three congruent sides. All three sides are the same length. Okay? So today we are looking at isosceles and equilateral, two congruent sides and three congruent sides. On isosceles triangles, the congruent sides are called legs. So here, these two sides are marked as congruent, so those are our legs. The third side is called the base, so the side that's not one of the legs, the non-congruent side, that's the base. And then the two angles adjacent to the base are called base angles. So here we have the base, the angles that form the base are called the base angles. Okay? So those are the parts of an isosceles triangle. The legs, the base angles, and then the tippy top, the angle that's not a base angle, is called the vertex or the vertex angle. Quick side note, base does not necessarily mean bottom. So no matter which way you turn this isosceles triangle, even if you turn it upside down, the base is still the base. It's the side that's not one of the congruent legs. So base is not synonymous with bottom, okay? It could be sideways, it could be upside down. Right? The base angles theorem, and we're going to look at a lot of variations on the same theorem. I'm not necessarily worried that you remember the names of the different theorems, but just that you know what the different properties are. So it says if two sides of a triangle are congruent, then the angles opposite them are congruent. So if side AB is congruent to side AC, well, B is opposite AC, and C is opposite AB. Opposite means across from. So if AB is congruent to AC, then angle B is congruent to angle C. Okay? So if the legs are congruent, the base angles are congruent. The converse to the base angles theorem says if the base angles are congruent, then the legs are congruent, right? Or if two angles of a triangle are congruent, then the angles opposite them are congruent. So this is just the opposite of this. This said, hey, if the legs are congruent, then the base angles are congruent. This says if the base angles are congruent, then the legs are congruent. So whether it's the legs that are marked or the base angles that are marked, we still know from either situation that these are isosceles triangles. So for example, on number 1, it asks you to name two congruent angles. Okay, so the base angles are congruent. So angle E is congruent to angle F. And then on number 2, the legs are congruent, so BC and AC. Right? So BC is congruent to AC. And these were questions that were on your pretest, so they will be on your post-test. but you guys did really well on these questions on your pretest. So go with your gut. You guys seem to understand this pretty intuitively. All right. So do this, you try. Pause the video and come back when you are done. All right. So on number 1, it says if HG is congruent to HK, then angle HGK, or angle G, let's say HGK, is congruent to HKG. Okay. So if the sides are congruent, then the base angles are congruent. All right. On number 2, you choose a new color. It says if angle, well, actually just let me erase these things. It says if angle KHJ, so KHJ, it's this angle here, KHJ, is congruent to KJH, so KJH, this angle here, then, so if the base angles are congruent, then the legs will be congruent. Okay. So KH is congruent to KJ. Okay. So number 1 is the base angles theorem. If the legs are congruent, then the base angles are congruent. Number 2 is the converse. If the base angles are congruent, then the legs are congruent. All right. So building on that base angles theorem and applying it to an equilateral triangle. If a triangle is equilateral, then it is equiangular. If it's equiangular, then it is equilateral. So if the legs are congruent, or excuse me, if the sides are congruent, then the angles are congruent, and vice versa. If the angles are congruent, then the legs are congruent. Critical thinking. What does each measure, or each angle measure, in an equilateral triangle? Okay? What's the measure of angle A, or the measure of angle B, measure of angle C? Okay, think about it for a second. All right, so remember, in a triangle, in any triangle, the angles add up to 180 degrees. And an equilateral triangle, all 3 angles are congruent. So 180 divided by 3 is 60. So each angle is 60 degrees in an equilateral or equiangular triangle. Okay. So on this example, it asks us to find the values of x and y. Here we've got an equilateral triangle and an isosceles triangle. Right? So in this isosceles triangle, it's asking us to find x. Well, we know that the legs of an isosceles triangle are congruent. However, we don't have anything on this other leg. But we know that equiangular triangles are also equilateral. So whatever this side is, the other sides are all the same. So if this side is 4, all the sides are 4. So that took care of y for us. Y is 4. without even having to do any arithmetic. But if this side is 4, hang on, right? If this side is 4, and this side is also 4, so x plus 1 is 4. So x equals 3. Right? So x equals 3, y equals 4. Because you got an equilateral triangle where all 3 sides are the same, and an isosceles triangle where 2 sides are the same. All right, so take that and apply it to this one. Find the values of x and y. Notice on this one, x is an angle though, okay? Keep that in mind. Okay, so on this one I'm going to start with y because y is going to be easier. So here we have an equiangular triangle, and remember equiangular triangles are also equilateral. So if this side is 4y, this side is 4y. This side is 28, this side is 28. Okay, so 4y equals 28. I'm going to divide both sides by 4. So y equals 7. All right. Now to find x is not going to be particularly hard, but there are going to be a few steps going on here, okay? So on x, we have an isosceles triangle, okay? These sides are the same. And on an isosceles triangle, the base angles are congruent, okay? So if this right one is 2x degrees, this left one is 2x degrees. Now it is up against an equilateral triangle or equiangular triangle. And remember, in an equiangular triangle, all the angles are 60 degrees. Okay? Now, this right here is a straight line. And a straight line measures 180 degrees. So this is a linear pair that measures 180 degrees. And 180 minus 60 is 120. So if this angle here is 120 degrees, because 120 plus 60 is 180. Okay, now I've got 3 angles, and I know the angles of a triangle add up to 180 degrees. So I'm going to say 120 plus 2x plus 2x equals 180. Okay? So 120 plus 4x equals 180. And subtract 120 from both sides. So 4x equals 60. Divide both sides by 4. So x equals 15. Okay? Y equals 7 and x equals 15. Okay? So there were quite a few steps on solving for x on that one. You have to solve, know that the angles of an equiangular triangle are each 60 degrees. Know that a linear pair adds up to 180. Know that the base angles of an isosceles triangle are congruent, and know that the angles of a triangle add up to 180. Okay? Nothing particularly complicated on its own, but there are quite a few things that you have to put together. So make sure you ask if you have any questions. Let me know if there's anything that I can explain, and I will talk to you guys later.